In Level 2, we will be manipulating and evaluating expressions that involve positive integer exponents. And to do this, we need to learn our properties of exponents. The first rule is called the product of powers, and the rule is if you multiply two exponential expressions with the same base, you add the exponents. So this would equal x to the a plus b. An example of why this works, say we did x squared times x to the fifth. What this means is two x's multiplied together times 5x's multiplied together, 1, 2, 3, 4, 5, and that is a total of 7x's multiplied together, or x to the 7th. So you can just do this by adding the 2 and the 5, and you get x to the 7th. The next rule is the quotient of powers, and when you divide two exponential expressions with the same base, you can subtract the exponents. So this would equal x to the a minus b power. And the reason that works, imagine you have x to the fifth over x squared. We have 5 x's on the top, 1, 2, 3, 4, 5, and 2 on the bottom. And anything over itself is 1 or cancels, so every x over x cancels out. So I have that pair of x cancels, this pair of x cancels, and we have 3 left on the top, we get x to the third. So by subtracting the exponents, 5 minus 2, we get x to the third power. The next rule is a product of powers, and when you raise a power to another power, you multiply the exponents. So this would be x to the a times b power. The reason this works, say you have x squared raised to the fifth power. This would be 5x squareds multiplied together. So x squared times x squared times x squared times x squared times x squared. And each of those x squareds is 2 x's, so that would be x to the 10th power. So again, raising a power to another power, you multiply the exponents. And then the 0 power, the rule is anything raised to the 0 power is just 1. Okay, so simplifying our expressions. In this first example, I'm going to multiply my regular numbers together. So I multiply -4 and 3, and I get -12. And then when I multiply x to the fifth times x squared, I add the exponents, and we get x to the 7th. And then I multiply y times y to the 8th. Now, this first y that doesn't have an exponent is like y to the first power. So I add the 1 plus the 8, and I get y to the 9th. In the next example, we're raising a power to another power, and everything inside gets raised to the 4th power, so I multiply the exponents. I get a to the 3 times 4, or 12th power, and times b to the 5 times 4, or 20th power. In the next example, I'm going to apply my quotient of powers rule. First, I would simplify 6 over 12. That's 1/2. So I put 1 over 2. And then I look at my x's, and I have x to the 11th over x squared. I subtract the exponents, and I get x to the 9th on the top. And then with the y's, y to the 7th over y to the 5th, again subtract the exponents, and we get y to the 2nd power on the top. Now I don't need to write this 1, so I would just write x to the 9th y squared over 2. And then for this last example, everything in here is raised to the 0 power, so it just equals 1. Anything to the 0 power is 1. These next two examples are a little more involved, but we're applying the same powers. In the first example, we would first raise everything inside parentheses to the second power. So everything gets squared. First I would do -3 squared, and I'm going to write that -3 in parentheses, and we have to remember to be careful when we square that negative number. It should come out to be +9. Then when I raise x to the fourth to the second power, I multiply the exponents and I get x to the 8th. And then I multiply the exponents for y to the 8th, raised to the second, and we get y to the 16th. Then I'm just going to bring down the second expression times 7x to the 11th. And then y to the 0 is just 1, and I don't need to write times 1. So that y to the 0 basically just goes away. Now I'm going to simplify. -3 squared is 9, which I can actually multiply by the 7, and we get 63. Then x to the 8th times x to the 11th, I add the exponents now, and we get x to the 19th. And then y to the 16th doesn't have any other y's, so we just leave it, y to the 16th. And that's our final answer. In this next example, you've got a few options. You could square everything first, so apply your exponent first, or you can simplify inside and then square everything. I think I'm going to simplify inside first, but it doesn't matter which order you do things. -15 over 27 can be simplified. Those can both be divided by 3, and we get -5 over 9. And then c to the third over c to the, this would be c to the first power if it has no exponent. If I subtract the exponents, we get c to the second on the top. And then d to the fifth over d squared, subtract the exponents, we get d to the third on the top. And now I'm going to raise everything inside to the second power. So we get -5 to the second. I multiply the exponents, so we get c to the fourth and then d to the sixth. And then we also have to raise this 9 to the second power. Now -5 to the second, remember -5 times -5 is +25. C to the fourth, d to the sixth over 9 squared, which is 81. And I don't think that 25 over 81 can be simplified, so that's our final answer.